Hello, my name is Lucas and I'm going to present the deep learning-based framework for shape instance registration on 3D CAD models. 3D CAD models are widely used in engineering projects, and the complexity grows by the year, posing challenges to efficient storage, transmission, and handling. User cells remove the redundant information by identifying instances of similar meshes and computing an affine transformation between them, but the method depends on vertex ordering and surface triangulation. By removing this redundancy, we can reduce the model representation and improve rendering. The question is, how to do that without depending on the mesh topology? Several techniques were proposed to perform shape-point cloud registration, but they are not well suited for the 3D CAD domain. Duerol in 2010 extended the ICP algorithm, obtaining an affine transformation for the point cloud registration. But, as we see in the further of the presentation, we are able to obtain better results with the proposed method. Inspired by the recent work, we developed a deep learning-based framework to remove redundant information of similar triangle meshes by relying on PointNet++ and obtaining an optimal affine transformation. By relying on point clouds, we are independent of vertex ordering and surface triangulation. We also guarantee an upper bound on any surface errors. The framework takes as input a triangle mesh, perform a preprocessing step, which composed by a normalization step, which the mesh is centralized in the origin and aligned with the 3D axis, and then a new uniform point cloud sampler. The sampler point cloud is passed to the PointNet++ and obtains the base type, which is used to perform the instance registration. On the instance registration step, our goal is to obtain a matrix M which transforms a source mesh into a target mesh. To do so, we have two loops. The outer loop, we continuously update the point cloud's density and check if the upper bound was already achieved. And in the inner loop, we use the AD optimizer alongside with the chamfer distance to continuously update M, stopping when the chamfer distance starts to decrease, avoiding loss of time in unconverging optimizations. We then discard this instance if the surface error is above an acceptance threshold, avoiding misclassification errors. And if not, we combine the matrix M with the denormalization transformation to obtain the final instantiation matrix. To evaluate the proposed framework, we used a CAD model composed by 1800 geometries labeled in 16 base geometry types. The final optimized model has a good quality, having a small mean surface error and standard deviation. When compared the memory reduction with the Ibsen and Sed's work, we were able to obtain a very close result to theirs. However, when shuffling the dataset, since the triangle meshes can have different triangulations due to different modeling techniques, we still maintain the same memory reduction, while the Ibsen and Sed's work perform poorly, since they are very topology dependent. We also perform a set of experiments using different methods for optimization with ICP, using our loops and not, and also the AD optimizer with chamfer distance. In this table, we can see that we were able to outperform the average time of all other methodologies, and although using a more relaxed acceptance threshold, the memory reduction were very close. When using a more rigorous one, we still maintain a good memory reduction, while the others start to perform poorly. Finally, we use the same base geometry types to optimize a different model, and the result was not as good as the previous one, due to the lack of similarities from the base geometry types. The misclassifications were pruned by the acceptance error. We presented the Shape Instance registration framework, which were able to obtain a significant memory reduction by relying on PointNet++ and AD optimizer, overcoming major drawbacks from previous works by relying on point clouds. As future work, we intend to investigate the use of clustering techniques to avoid the necessity of previous known knowledge about the model, and apply the framework in other scenarios.